You're Napot. Well, that's the way we say hello in Hungary. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics and to make your mathematics strong. So, children, before we get started and learn about solving equations, I'd like to tell you about this picturesque place, which is Lake Heves, Zala County, Hungary. This is the largest swimmable thermal lake in the world. It is here where mosquitoes dread to come, because this Lake Heves is where resides toothfish, which has a great appetite for mosquitoes and breeds on it. Further, the water replenishes itself magically in 72 hours. It is a place where Hungary is said to be doing water tourism, as Lake Heves is great for spa for people with rheumatic disorders and locomotor disorders also. Now, if you are to go to this place, make sure to have Turo Rudi, which is an awesome sweet dish, as I can tell you. It is really mouth-watering. And do remember to tell all the people of Hungary that you get to meet your Napot. In this note, children, I'm going to start off this lecture of telling you people about how to solve equations which have variable index. Now, if you're to learn how to rock solving such equations, make sure to stay till the end of this lecture, and I can vouch to you that you're really going to enjoy this lecture. So let's get started, children, and let's look up a little bit of rules about indices, a little bit of rules about logarithm, as you already learnt it in earlier lectures, which you can easily refer to. I'm sure using these rules very easily, you'll be able to solve this equation which I'm going to give you. It has come in the Olympiad, so obviously you can then boast to be able to solve a question of mathematics Olympiad. Okay, children, so tell your people a little about the rules of indices. Remember, children, if you talk about indices, then we mean to say that there is some number which is at the index of some other number which is at the base. For that matter, if say we talk about a number which is of the form of a raised to the power x, then you say that this is in the exponential form. Now, the first rule that we can talk about is if you talk about a raised to the power m, which gets multiplied with a raised to the power n, then that becomes equal to a raised to the power m plus n. Further, if you talk about a number which is a raised to the power m, and if it is divided with a raised to the power n, then that becomes equal to a raised to the power m minus n. Then further, if you talk about a raised to the power m, which is whole raised to the power n, then that becomes equal to a raised to the power m into n. So these are few very important rules which you learn in indices, and I'm sure you must have learned in the earlier lecture. Okay, now children, if we talk about logarithm, that is another very important topic, logarithm, which is essentially required in mathematics and also in subjects which require mathematics, like if you talk about physics, chemistry, or many other sciences, and even in economics. So when we talk about logarithm, children, these are few very essential rules which we apply again and again, and I'm going to tell it to you again so that you are well revised before we go along with the sum. So if say we talk about some log of a product of two numbers, that is a into b, then that, children, becomes equal to log of a plus log of b. Further, if you have a log of a ratio of two numbers, that is a upon b, then that becomes equal to log of a minus log of b. Right? Further then, children, if we talk about log of a raised to the power m, then that becomes equal to m times of log of a. That is when we have log of a number, where you got to remember that whenever you are to find out the log of a number, that number should always be a positive number. So children, these are few rules. I'm sure this is just like a revision. Even then, I'm going to quickly repeat to you the rules so that you are well abreast with it when we go ahead with this special sum. So if you have two numbers which are in the exponential form, and if say they are multiplied such that they have the same base, then keeping the base to be the same, you will add the indices. Further, if you have the ratio of two numbers which has the same base, then you'll have the same number at the base. However, in the exponent, you will have the difference of the numbers which were there in the exponents. Then if there is a number in the exponential form, just like a raised to the power m, if it is raised to the power n, then that will become equal to a raised to the power m, which is multiplied with n. Further children, if there is a number whose logarithm is being taken such that if you talk about log of a into b, then that's going to become equal to log of a plus log of b. Then if you have log of a upon b, then that's going to become equal to log of a minus log of b. Now if you have a number log of a raised to the power m, then that's going to become equal to m times of log of a. So these were a few rules. Now children, is the special sum. This is that sum. I like you people to initially give it a try. I'll give you some little time for trial. If you want more time, then what you can do is you can pause the lecture and give it a big try. Okay children, let's get ahead with this interesting sum. Now the problem with the sum is you get to see that the base of one of the exponential numbers is 2 and the base of another exponential number is 5 here, right? So as such, trying to apply the rules of indices is going to be a little difficult. So to be able to do the things, first what we do is we can write this as 2 raised to the power x, which is equal to 5 raised to the power x, which is multiplied with 5 raised to the power 2, as I'm sure you remember that if we talk about a raised to the power m, which is multiplied with a raised to the power n, then that becomes equal to a raised to the power m plus n. So here too, this is the rule that we've applied. So further what we can do is we can write this as 2 raised to the power x, which is divided by 5 raised to the power x, which becomes equal to 5 raised to the power 2, which obviously further can be written as 25. So thus we have 2 upon 5, which is whole raised to the power x, and that can be written to be equal to 25. Now next children, here what we can do is we can take the logarithm of both the sides. So here what we say is taking logarithm, as this is a positive number, so obviously there's not going to be any problem in taking the logarithm. So here further you will say that log of 2 upon 5 raised to the power x is going to become equal to log of 25, right? Up to here, do you have any problem, Shivansh? Rest everybody? Sure, right. So next children, I'm sure you people remember that there is another rule which tells us that if you have log of a raised to the power m, then that becomes equal to m times of log of a, as we've just looked up. So here further we're going to do the same, that is we will write this as x times of log of 2 upon 5, right, and that is equal to log of 25, right? Now very easily, I'm sure you can see that we can make x the subject of the equation. As such, x can now be written as log of 25, right, which is going to be divided by log of 2 upon 5, right? So here children, as these are constants, so for the next now what you're going to do is if you find out the value of log of 25, which can further be simplified as log of 5 raised to the power 2 whole divided by log of 2 upon 5, which can thus be written as log 2 minus log 5, as we know this rule that if we talk about log of a upon b, then that becomes equal to log of a minus log of b, right? As such, we've used this. And now remember, we have talked about another rule in logs, that is log of a raised to the power m is m times of log of a. So we're going to apply this here again. As such, this 2 is going to come forward as a number multiplied with log 5. So further this can be said to be log 5, which is now going to be multiplied with 2. And then in the denominator we have log 2 minus log 5. Now here children, we can solve this further, as we know that log 10, right, to the base 10 is 1 if we consider common logarithms, that is when the base of the logarithm is 0, which are also known as decimal logarithms, which are also known as Bulgarian logarithms, which are also known as decadic logarithms, right? So if you consider these logarithms to be one that have base 10, then to get to this exact value is pretty simple, as we can say that log 10 to the base 10 will become equal to 1, right? However, talking about the value of log 2 to the base 10, it is also known to be 0.3010, so we can get to the exact value of it. But if the base is general, that is E, that is Euler's number, right? Remember, all of these things that I told you just now has been discussed in the earlier lecture in detail about logarithm, which I'm sure very easily you can access, right? Then you will be able to find out all of these values if you talk about using the base as the general base, that is E, and then its values can also be calculated. As such, here we've made x the subject of the equation and we've been able to calculate its value. As such, this is going to be the final answer. Right now, children, I'll quickly be discussing all of this all over again, so that if there is any confusion, yes, Shivansh, all of that will get with it. So children, in this question we've been given here that there is one equation where you've got to find out the value of the unknown, that is x. Now the equation is 2 raised to the power x is equal to 5 raised to the power x plus 2. Now here what you do is, the problem is what you see first is that the base of the numbers which are in the exponential form are not the same. One is 2 and the other is 5. So how do you deal with it is, first you talk about this 5 raised to the power x plus 2 in accordance with this rule, which is just like a raised to the power m plus n can be written as a raised to the power m into a raised to the power n, right? As such, here this can be written as 5 raised to the power x multiplied with 5 raised to the power 2. Now next what we do is, if we talk about bringing this 5 raised to the power x to the denominator, there can be a lot of benefit. So what we do is, we can now write this as 2 upon 5 whole raised to the power x, as when this is expanded, both of the numbers will have the powers as x. Now remember, power is a synonym of exponent, which is further a synonym of index. Index in plural is said to be indices, right? So that is how these are related. Okay, next now children, after this step, we now next take logarithm. So when we take log of both the sides, here what we do is, we can say log of 2 upon 5 whole raised to the power x is going to be equal to log of 25. Now this is possible to be used, that is log of a raised to the power m is m times of log of a. So here what we do is, we bring this index forward. As such, x times of log of 2 upon 5 is equal to log of 25 is what we can write. Now children, this is the time when we can make x the subject of the equation. As such, x can then be written as log of 25 divided by log of 2 upon 5, by bringing log of 2 upon 5 to the denominator of the other side. Now children, this 25 can be written as 5 square. So again, as we know that if we talk about using this rule, that is log of a raised to the power m is going to become equal to m times of log of a. So here as such, we can write this as 2 times of log of 5. Further, if we have log of a upon b, we know that that's going to become equal to log a minus log b. As such, here we will have log 2 minus log 5, right? So next children, what we can do is, this is what the final answer is going to be. Now you can calculate this if you talk about the base to be 10, that is if the logarithm is a common logarithm, because this 5 can be written as 10 upon 2, right? Then again it can be written as log 10 minus log 2. As you know that the value of log 2 is 0.3010, so very easily the numerator can be calculated, and similarly the denominator also. But here, if suppose you talk about the base to be the general base, that is E, then further with a little bit of complication you can even calculate that, right? However, your task was just to find out the value of x, and you found it out even if the base is 10, that is the decimal base, or even if it's the general base, that is when the base is the Euler's number E. So this is what you have to do in the sum. So has everybody been able to understand this? Shivansh, Devanshi, everybody clear? Did you enjoy this lecture? I'm sure because you stayed to the end of this lecture, you've been able to understand this. But I want one thing that you can do. I want you people to pause this lecture immediately, write the question once more, and as you understood the solution all over, right? So I want you people to do this question once again in your copies, and that is how the question is going to register in your brains. And if suppose somehow, sometime this question comes, then I'm sure you're going to crack it with ease. So children, this is all I had to tell you people in this lecture. I hope you have enjoyed this lecture, and do tell me what is the special thing that you liked in this lecture. What is this that you can say that you want to study in another lecture that I can help you with, right? Moreover, if you want to be helped further, right, there are free courses that I have. Do write to me in my email ID, which is saurabhkumardut@gmail.com, and I'm going to revert to you. Moreover, if you look up in the link, there are some courses that you can subscribe to, and you will get to know more about maths, and your query as well as your scare in maths is going to die down. So bye children, have a nice time. This is Saurabh Kumar Dutt signing off, and I'm sure you're going to log in for more to learn more of maths in a very easy way. Bye.